F8, 2.1, Understanding Scientific Notation, Part 2. So last time we talked about what it takes to be in scientific notation. This number itself must be greater than or equal to 1 and less than 10, and it must be times 10 to a certain power. So let's continue on page 62 with example 2. A says, write each number in scientific notation, 427.7. So what we're going to do is write that so that this number itself, right here, is greater than or equal to 1 and less than 10. Which means that we are going to bring the decimal place over 1, 2 times 1, 2, 4.277 times 10. Since we brought the 0 over twice, 1, 2, and it's to the left, it's 10 to the power of 2. Because when we multiply this number back out, we know that we would bring the decimal place this way, 1, 2, and it would be equal to that again. So we can check it by going backwards again, and we can see that it's correct. So this is our answer. And that is also equal to 4.277 times 100. But this is how you write your answer in scientific notation. Let's try B. 0.007 equals, well, we're going to want to go over 1, 2, 3 times. So that is equal to 7 times 1, 2, 3, 10 to the negative 3, because it's also equal to 7 times 1 over 1,000 equal to 7 divided by 1,000. All of these are equal expressions, but this is how it's written in scientific notation. If we want to check it, we would do 7 divided by 1,000, which equals 1, 2, 3, 0.007, and it checks out. So go ahead and try this on guided practice 4 and 5. Moving on, write numbers in standard form. Okay, good morning.
Okay, if I use this.
The room? Yeah, I think so. Okay, write numbers in standard form. So let's try an example. Example 3. A, 7.1 times 10 to the third. So in order to write it in standard form, basically we're going backwards. So that's equal to 7.1 times 1,000, because it's power of 3, so 3 zeros, and that equals 7, 1. We go over 1, 2, 3 times. So 1, 2, 3 times, and that is equal to 7,100. Let's try it with B. 8.12 times 10 to the negative 3 equals 8.12 times 1 over 1,000, which is also equal to 8.12 divided by 1,000, which is equal to 1, 2, 3, 0.00812. Try that in guided practice 6 and 7. Next, we're going to compare numbers in scientific notation. So you can compare them by writing them in scientific notation, because you don't have to compare the whole number, you can just compare the powers. So in A we have 5.6 times, oh, I'm going to rewrite that. 5.6 times 10 to the power of 2, and 2.1 times 10 to the power of 3. So now we can just look at the exponents, and we can see that 10 to the power of 3 is greater than 10 to the power of 2. Therefore, 2.1 times 10 to the power of 3 is greater than 5.6 times 10 to the power of 2. We don't even have to look at these numbers unless these are the same, but since they're different, we can compare those first, and this would be our answer. Let's try that again. B, 3.4 times 10 to the negative 1, and 1.1 times 10 to the negative 1. So now we're going to compare, and you'll see, okay, the coefficients, 10 to the negative 1 is equal to 10 to the negative 1, so we can't compare those. Now we can compare these numbers when these are the same. So we could say that 3.4 is greater than 1.1, therefore 3.4 times 10 to the negative 1 is greater than 1.1 times 10 to the negative 1, and that is our answer. Go ahead and try this on guided practice 8 and 9. Okay, let's try example 5. I forgot to write example 4 here. That's what that was. Now we're moving on to example 5. So in 2000, Americans consumed an average of 47.2 pounds, this is the abbreviation for pounds, of potatoes, and 5.936 times 10 to the power of 2 pounds of dairy. So this is dairy, this is potatoes. And did Americans consume more potatoes or dairy products? So to do this, we can use two methods. Method 1, we are going to convert both of these to just their standard form, so 47.2, and this one is times 100, so it becomes 593.6. So we can see that 593.6 is greater than 47.2, so they had more dairy. Or in method 2, we could just compare the powers, so we could put them both in scientific notation. This one would be 47.2 equals 4.72 times 10 to the power of 1. And this one would be 5.936 times 10 to the power of 2. We can compare. 10 to the power of 2 is greater than 10 to the power of 1. Therefore, 4.72 times 10 to the 1 is Therefore, we could say 5.936 times 10 to the power of 2 is greater than 4.72 times 10 to the power of 1. And that would tell us that there is more dairy as well. So you get the same answer both ways. Go ahead and try that in guided practice 10, 11, 12. That's all for today.